Good day, students. Now continue the solving the examples on the first remarkable limit. Consider the number example number 468. 68. Find the limit. Find the limit. Find the limit. 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 When x tends to 0, cosine 4x minus cosine 6x over sine squared 5x. Solution. We can solve this example by three methods. First, substitute 0 instead of x. Cosine of 0 minus cosine of 0 divided by sine squared of 0. Cosine of 0 is 1 minus 1, and sine of 0 is 0, and we obtain the indeterminate form of type 0 over 0. First, consider first method of remarkable limits. First, transform the numerator in the following form. Limit when x tends to 0, 1 minus cosine 6x minus 1 minus cosine 4x divided by sine squared, sine of 5x squared. We can rewrite this expression, rewrite the denominator in the following form. Then divide numerator and denominator by x squared at the same time. Divide by x squared. Equals limit when x tends to 0, 1 minus cosine 6x minus 1 minus cosine 4x over x squared divided by sine 5x squared over x squared. Then divide the numerator term by x squared, and here we can unite the expression and the square. Limit one minus cosine 6x over x squared minus 1 minus minus 1 minus cosine 4x over x squared divided by sine 5x over x squared. Then continue. Now make the following changes. Change change 6x by t, change 4x by z, and change 5x by y. Change. Press change. 6x is t. 6x is t. Then x is t over 6. If x tends to 0, then t also tends to 0, because 6 multiplied by 0 is 0. X tends to 0, then t also tends to 0. Second change, 4x is z. 4x is z. Then x is z over 4. If x tends to 0, then z also tends to 0, because if substitute 0 instead of x, then we will obtain that z also tends to 0. And third change, 5x is y. 5x is y. Then x is y over 5. Y over 5. And if x tends to 0, then y also tends to 0. Continue. Here we can separate. We can distribute the limit symbol for all terms. Limit when x tends to 0 of 1 minus cosine 6x over x squared, minus limit when x tends to 0 of 1 minus cosine 4x over x squared, and divided by limit when x tends to 0 of sine 5x over x squared. And then using these changes, we can rewrite the last expression. Then limit when t tends to 0, 1 minus cosine t divided by t over 6 squared. T over 6 squared. Minus limit when z tends to 0 of 1 minus cosine z over instead z over 4, substitute z over 4 instead of x. Z over 4 squared. Divided by limit when y tends to 0. Here we use the third change, sine y over y divided by y over 5 squared. Squared is used for whole ratio. I'm sorry. X is x y over 5 squared. And continue. We have it is t squared over 36, and 36 is transferred to the numerator. Limit when t tends to 0, 36 multiplied by 1 minus cosine t over t squared. T squared. Minus limit when z tends to 0. Here we'll obtain z squared over 16, and 16 can be transferred into numerator, into the numerator. 16 multiplied by 1 minus cosine z over z squared, divided by we can introduce limit in the denominator under the square symbol, and here 5 can be transferred to the numerator, and then we will obtain 5 squared is 25. Limit when y tends to 0, 5 sine y over y squared. Then continue. Further, we can take the constant factors out the limit symbol. We can take 36 out of the limit symbol, take 16 out of the limit symbol, and 5 out of the limit symbol. Continue. Limit 36 multiplied by limit when t tends to 0 of 1 minus cosine t over t squared minus 16 multiplied by limit when z tends to 0, 1 minus cosine z over z squared divided by 25 multiplied limit when y tends to 0, sine y over y squared equals. Then remember the cosine result of the first remarkable limit. According to the cosine result of the first remarkable limit, this limit is 1 second, and the second limit is also equal to 1 second. But it is the first remarkable limit itself, and it is unit. Then we have 36 multiplied by 1 second minus 16 multiplied by 1 second divided by 25 multiplied by 1 squared equals 18 minus 8 divided by 25, 10 divided by 25, simplified by 5, and then we will obtain 2/5. Our answer is 2/5. Then go to the second method. Name the trigonometric method. Second method. Trigonometric method. Remember the formula of cosine's difference. Cosine alpha minus cosine beta equals minus 2 multiplied by sine of alpha plus beta in half multiplied by sine of alpha minus beta in half. in half. And using this formula, rewrite the numerator. Limit when x tends to 0, minus 2 multiplied by sine 4x plus 6x in half, multiplied by sine 4x minus 6x in half, divided by sine squared of 5x equals. Then here we can take minus 2 out of the limit symbol, because minus 2 is a constant factor. Minus 2 multiplied by limit when x tends to 0, sine of 5x multiplied by sine of minus x, minus 2 divided by in half, minus x, divided by sine squared 5x. Then we can simplify numerator and simplify this fraction by sine 5x, and also you know that the sine is an odd function, and therefore we can take negative sign of the sine symbol. Minus 2 multiplied by limit when x tends to 0, minus sine x over sine 5x equals, and then we can take the negative sign also out of the limit symbol, and in result we will obtain simply 2 multiplied by limit when x tends to 0 of sine x over sine 5x, and already you know the calculation method of this limit. It is 1/5 multiplied by equals 2 multiplied by 1/5, and it is 2/5. And you see that we obtain the same result. It is second method. Finally, consider the last method, that is the method of equivalent forms. Third method, equivalent forms, equivalent forms. Here we will use the following equivalent forms. For numerator, we must use the equivalent form of cosine x. Cosine x is equivalent to 1 minus x squared in half if x tends to 0. And the equivalent form of sine x. Sine x is equivalent simply to x when x tends to 0. Rewrite limit when x tends to 0. If x tends to 0, then also for x tends to 0, 6x tends to 0, and 5x tends to 0. For x tends to 0, 6x tends to 0, and 5x tends to 0. Then we can apply these formulas. Cosine 4x, we must substitute for x instead of x, and there we must substitute for x. 1 minus 4x squared in half minus, then substitute 6x instead of x. 1 minus 6x squared in half divided by sine squared 5x. I'm sorry, we can write it is equal sine 5x squared, and remember that for x, if its argument tends to 0, we can remove the sign symbol. Therefore, we can change by equivalent form 5x squared. Here we can delete sign symbol and write in the denominator 5x squared. Continue. Equals a limit when x tends to 0 is 1 minus 16x squared in half is 8x squared minus 1 plus 36 squared in half is 18x squared, and here we have 25x squared. Here 1 and minus 1 are removed. Minus 8x squared plus 18x squared will give 10x squared. Limit when x tends to 0, 10x squared over 25x squared. Limit when x tends to 0, 10 over 25, it is constant, and the limit of constant is equal to the constant itself, 10 divided by 25, then simplify this fraction by 5 and we will obtain 2/5. And you know that you see that we obtain the same answer, 2/5. Further, consider next example number 489. Limit when x tends to 1 second, arc sine of 1 minus 2x divided by 4x squared minus 1. Here we must substitute 0 instead of substitute 1 second instead of x. Arc sine 1 minus 2 multiplied by 1 second divided by 4 multiplied by 1 second squared minus 1 equals, it is 1. 1 minus 1 is 0. Arc sine of 0 divided by 1 second squared is 1/4. 4 multiplied by 1/4 is 1. 1 minus 1 is 0. Arc sine of 0 is 0, and we obtain the indeterminate form of type 0 over 0. We can solve this example by change of argument of arc sine by new variable. For example, let 1 minus 2x is t. Change or substitution. Change. One minus 2x is t. Then 2x is 1 minus t, and x is 1 minus t in half. And also we must change the limit tendency. If x tends to 1 second, then substitute 1 second instead of x in this change. 2 multiplied by 1 second is 1, 1 minus 1 is 0. It means t will tend to 0. Use this change in the given expression. Limit when t tends to 0, arcsine t over 4 multiplied by 1 minus t in half squared minus 1. Then limit when t tends to 0, arcsine t divided by denominator squared is 4. 4 multiplied by 4 and 4 can be simplified, and therefore we will have only 1 minus t squared minus 1. Then transform the denominator, limit when t tends to 0, arcsine t over 1 minus 2t plus t squared minus 1. Here 1 and minus 1 are removed. Then we have limit when t tends to 0, arcsine t over t squared minus 2t. Then we can take t out of the bracket, out of the parentheses in the denominator. Limit when t tends to 0, arcsine t over t multiplied by t minus 2 equals. Then separate expressions in the expression under limit symbol. Limit when t tends to 0 of arcsine t over t multiplied by 1 over t minus 2. Here we have the product, and you know the limit of the product is the product of the corresponding limits. Limit when t tends to 0, arcsine t over t multiplied by limit when t tends to 0 of 1 over t minus 2. The first limit is the arcsine result of the first remarkable limit, and it is unit. And here in the second limit we must substitute 0 instead of t. Then we will have 1 multiplied by 1 over 0 minus 2, and it is minus 1 second. Our answer minus 1 second. 1 second. Please rewrite. Now go to the second remarkable limit. Second remarkable limit, right? The second remarkable limit. The second remarkable limit. First formula. Limit when n tends to infinity of 1 plus 1 over n raised to n is e. It is formula 1a, 1. First formula. Here we have the indeterminate form of type of 1 to infinity. Because if substitute infinity instead of n, 1 over, we will have 1 over infinity is 0, 1 plus 0 is 1, 1 to infinity. 1 to infinity is indeterminate form. One of indeterminate forms. Here e is a constant value, and it is approximately equal to 2.7. 2.7. Constant value. It is constant value. And the second remark limit can be rewritten in the following form. Also in the following form, 1a. Let it is 1a. Limit when x tends to 0 of 1 plus x raised to 1 over x is e. It is another form of the second remarkable limit, and it is also the indeterminate form of type 1 to infinity. 1 to infinity. And this formula more popular for calculations. Then write the results of the second remarkable limit. First, write the logarithmic result. The logarithmic, the general logarithmic result. General logarithmic result. Logarithmic result. Limit when x tends to 0 of logarithm on base a of 1 plus x over x. And it is 1 over natural logarithm of a. Here we have the indeterminate form of type 0 over 0. Because if substitute 0 instead of x, here we have 1, and any logarithm of 1 is 0. 0 divided by 0 is indeterminate form. Then we can write the natural logarithmic result. The natural logarithmic result. Natural logarithmic result. Logarithmic result. If a is e, then we obtain the natural logarithmic. If the base of logarithm is e, it means the general logarithm is transformed into the natural logarithm. Then limit when x tends to 0 of natural logarithm of 1 plus x over x equals natural logarithm of e is unit by unit, divided by unit is unit. And it is also 0 over 0. It is the natural logarithmic result. Later continue. Then write the exponential result, the general exponential result. The general exponential result. Exponential result. exponential result, exponential in Azeri üstlü, in Russian показательный. That is umumi üstlü netice. In Russian общее показательное следствие. Limit when x tends to 0, a raised to x minus 1 over x is natural logarithm of a. It is exponential result, general exponential result, and it is in the indeterminate form 0 over 0. Because if substitute 0 instead of x, then we will have a raised to 0 is unit minus 1 is 0, 0 divided by 0. Then 3a, formula 3a, the natural logarithmic result. The natural logarithmic result. I'm sorry, exponential result. Here substitute e instead of a. And you know that natural logarithm of e is unit. Limit when x tends to 0 of e to x minus 1 over x is unit. Indeterminate form of 0 over 0. And finally write the power result, in mathematics power is in Azeri is kuvvet and in Russian is степень. Kuvvet neticesi степенное следствие. Limit when x tends to 0 of 1 plus x to n minus 1 over x is n. Here also we have the indeterminate form of type 0 over 0. Because if substitute 0 instead of x, we have 1 plus 0 is 1, 1 to n is 1, 1 minus 1, 0, 0 over 0. Then continue. Now write the corresponding equivalent forms, that is equivalent forms for the logarithmic, exponential and power function. Write the equivalent forms. Equivalent forms. If the argument we'll write this equivalent forms if x is situated near 0, that is if x tends to 0. Equivalent form for the general logarithmic function. General logarithmic function, and let it second point, because first point is for the second indeterminate second remarkable limit itself. Second point for general logarithmic function. Logarithm on base a of 1 plus x is equivalent to x multiplied by x divided by natural logarithm of x. X divided by natural logarithm of a. If x tends to 0. 2a for natural logarithm of 1 plus x is equivalent to simply to x when x tends to 0, because natural logarithm of e is unit. Natural logarithm of e is unit. Then third formula for the general exponential function. A to x is equivalent for 1 plus x multiplied by natural logarithm of a when x tends to 0. Next equivalent form for the natural exponential function 3a. E to x is equivalent to 1 plus x, simply plus x, because natural logarithm of e is unit when x tends to 0. And finally, write equivalent form for the power function 1 plus x to n is equivalent to 1 plus n multiplied by x when x tends to 0. These equivalent forms can be used for the calculation of the limits connected with the second remarkable limit and its results. Now please rewrite homework the limits on only the first remarkable limit. Please rewrite, and goodbye students. I wish success for you. Good luck.